So what this video is going to go over is a discussion on what we call forces between charges. And so this is leading up to a very important law that we're going to be kind of developing here through a course of some data that we're going to be looking at. So we are going to be focused on, again, the atom and the fact that the protons are positive and the electrons are negative. And so we know that scientists understood at a very early time that there was an interaction, there was an attraction between a positive and a negative. So what we're going to look at is some data. Okay, now this data is not, it's more appropriate for, say, a physics discussion, but we're going to use the data to kind of see a pattern. And that, again, is going to be the focus we're going to have throughout all of this unit. So I have a set of data here with charge 1 and charge 2. So we could think of this as a proton being positive, and we could say charge 2 is an electron. We could also take it to as a cation versus an anion. So we could also bring it to the ionic side of things as well. So we're going to kind of parallel those discussions. So if this confuses you, I would suggest you kind of make this a table of data so that you could kind of visually see what is taking place or what we're looking at. So what we're comparing is essentially a different situation to each other and seeing what is happening to the force between these two charges. So we have in situation A, we have a positive one and a negative one, and we have a particular distance between them. So I want you to think of two magnets coming together, and we could bring it to a certain distance, and that distance is then going to give us a force. So again, think of two magnets coming close together. So I have a force in newtons, again, not going to be a big focus of this discussion. It's more to look at data. So I'm going to look at situation A versus situation B, and I'm going to see that my charge is in situation A to B is +1. From charge is going to be -1 to -2. So essentially what is happening is I am doubling the charge. And I want to take a look at what is happening to force. So force is going from 90 to 180. So what we're going to be doing is writing some statements or making some observations about this data. And so we're comparing A to B. Okay, what is the change? What is changed between these two situations? So I'm changing charge 2, I am doubling it. Okay. So you could also write double as ×2, if that makes sense, okay? What is kept constant between these two situations? Well, charge 1 is still +1, okay? So charge 1 is still +1, and my distance is still 1 meter, okay? So those two are remaining constant. So what happened to the force between the two charges? Well, the force doubled, or you could say multiplied by 2. So it went from 90 to 180. So then we're going to compare situation A to situation D. Okay, so we're going to look at A versus D. So I'm going to put this up here so we can kind of see. So charge 1 is going from +1 to +2. Charge 2 is going from -1 to -2. My distance is staying the same. And then I'm looking at my force. I'm going from 90 to 360 here. So what has changed between the two situations? Well, charge 1 and charge 2 are both doubling. Okay, going up by a factor of 2. So again, you could write the word double, or you could just say multiplied by 2. What has happened to the force between the two charges? So I'm going from 90 to 360. So again, if you need to do the quick math, okay, you're seeing that it's going up by a factor of 4. So I'm multiplying the 90 by a factor of 4, going up to 360. So what is the pattern, do you notice, between charge 1 and charge 2 and the force? Well, as I increase the charge, okay, let's say I double the charge, the force is going to go up by the same factor. Okay, so what I did to charge is what happens to force. I also see it here because charge 1 was doubled, charge 2 was doubled, and 2 times 2 is a factor of 4. So again, that is the relationship between charge and force. So what we're going to be writing here are what we call relationship statements to see what is the relationship between charge and force. Okay, so we're going to be writing a statement here. So we're going to write, I'm going to pause the video and then come back. So back on the video here, my relationship is between charge and force. This is what we call a direct relationship, and I'm underlining that word direct. We're going to be using some of these words for our relationship statements. So the relationship between charge and force is direct, okay? Charge increases proportionally to force if distance is held constant. Okay, so charge increases proportionately to force if distance is held constant. So again, we kept distance the same. All we were looking at is the relationship between charge and force. Okay, it's a proportional relationship. So whatever I do to charge is what happens to force, whatever happens to force. Okay. So on the next page, I have some blanks here in the chart. So I want you to fill out the rest of this chart. And then in a moment, I'm going to pause the video. And then in a second, you're going to see the answers. And you could kind of see if you got the same answers that I did. So here we see the force went up by a factor of 2. So obviously my charge must go up by the same proportion. Then for G, I am doubling charge 1 and I'm doubling charge 2. So that's going up by a factor of 4. So 2 times 2. So that's going to be 50 times 4. So that gives me 200. And you always want to go with like the first situation. That's going to be the number that you kind of use. And then finally, situation H, 3 and 3. So essentially, I'm multiplying it by a factor of 9 because whatever I did to charge, 1 and 2 is going to be what I do. So I get a 450 as my answer. Okay, so again, with all of these situations, can you tell me what is held constant, what is changing, how does it affect the force, and can you write a relationship statement for this? Okay, so that's what that is focused on.